What's up, guys? My name is Ben. You're watching Pragmatic Software Engineering, and today we're going to talk about this thing called hashing. Now, hashing is used in certain data structures, and it's also used in DevOps and other applications of programming. I want you to consider an application we're building. This application allows our customers to upload images, and we want to make sure that we don't have a single duplicate image. There are many customers using this application, and we have to be very careful with our storage. How can we ensure that nobody uploads a duplicate image? If you think we can rely on the file name, think again. Somebody could have accidentally renamed an image. There has to be a way where we can figure out if the image is already present on the system. We can probably do this by comparing the image files or the bytes inside. We can start comparing these to other images found. But that will be a very expensive and slow process. This is where hashing can be used to save the day. Hashing takes any sort of data and performs a transformation on it, reducing it to a string or a number that's very small compared to a huge file. Hashing is a transformation you can apply on any piece of data. It is one way. If you call a hash function on any piece of data an infinite amount of times, it will always produce the same result. If you have a bad hash function and you hash two different pieces of data and get the same result, this is called a collision. A good hash function does not produce many collisions. You may have heard of different algorithms that we can use to hash. I can think of three, but there are many more. SHA-256, SHA-512, and MD5. Another use case that hashing is used for is passwords. Now, if we have a customer registering to use our service, they're going to give us a username and a password. We're going to store the username. If we store the password and we get hacked, it's a really big deal for our customers, and we could get into a whole lot of legal trouble. So what we can do is, instead of storing the actual password, we can store a hash of the password. And this is totally fine, because if a user tries to log in, they're going to give us a password, and we have the hash of their real password and a potential password. When the customer hands in a password in a login form, we simply use the same hashing algorithm, and we see if the two strings or the two result hashes are the same. Now we have found a way to correctly identify a user without storing their password on our servers. Let's look at some examples with the terminal on how to use hashing. I want to show you how powerful hashing is. In this example, I am in a terminal. I have three files here. Two of the files are exactly the same. One file has one character difference, and I want to identify which one has the character difference. Traditionally, I would view them with something like less or vim, basically something that outputs what the actual file contents are. Let's do it. Yes. So look how awful this is, right? So I go through, I have to figure out which one. Oh my goodness, this is disgusting, right? Oh gosh, my eyes. Let's get out of this, Let's get out of here. So, again, one of these files is different from the other. But what I can do, actually, is use some sort of hashing algorithm to figure out which one is the unique one. So, I'm using Arch Linux, but Linux usually has something like an MD5 sum. Or you could use a SHA-512 or some other SHA sum here. I'm going to use MD5 because that's the one I'm most familiar with. So if I MD5 sum star, I can see that ArrayList2 and ArrayList themselves are truly the same exact file, but ArrayList1 is different. That's correct. I did change ArrayList1 to have a different character inside. The hashing algorithm is savvy enough that it found that difference and rendered a different hash. Now here's another example. We're looking at passwords, and due to the nature that hashing is a one-way transformation of data, meaning if you hash something, and you have that result, that hash that comes out, you cannot unhash and get the original data. You can use it for checking passwords. And now what we can do is we can try different passwords. As an example, let's try a password. And let's pipe it through the MD5 hash some. Oh, that's not it. Well, let's try 1, 2, 3, 4. No, okay. What about pragmatic? Oh, would you look at that? They match. So what is really interesting about using a hash for a password? Well, you don't ever need the original password. So if you use a hash function to transform, let's say a user puts in a password they want to put into a system they're registering, well, you can use that hash to protect their original password. And every time that they try to log in and use a password, they use that hash function again, and they just compare the results to the hashes. All right, so that was hashing. I hope you understand it. Let me know if you don't. Please send me a message, send me an email, comment on some of our videos or our blog posts as well. I hope this was helpful. Please show us to your friends, hit like and subscribe. Thank you very much. Bye.